Hello, in this set of videos we're going to concentrate on the next part of cross-country flight planning, specifically figuring out your distance, your ground speed, your time, and your fuel en route. In my last series of videos I went through plotting a true course, determining your true heading, figuring out what your magnetic heading was, and then finally getting your course heading. So if you haven't seen those series of videos first, I suggest you go ahead and look at them because it'll really help you out and get you started on this one. So, okay, let's go and get started. So let's say you were filling out a flight planning form. Next thing you needed to do is figure out what your distance is. And really on your distance on your flight planning form, you're figuring out whatever your distance is, so to speak, between 2 points. That point being, your point of origin or your destination, or your point between your checkpoints, if you will. So let's just go ahead and give you a couple examples of that. So we'll go back to good old Houston, Texas, for example. And let's say we were going to go from Ellington, which is right here, down to Galveston. Alright, so there we go. Ellington to Galveston, right there. Well, we already know that our heading is going to be 143 degrees. But what we need to figure out is figure out our distance. Now, if you were measuring this on a sectional, what you would do is you would just simply use either your plotter or your E6B or some other type of measuring device to figure out what your distance is. And you can really use whatever units you want. You can use miles, or you can use nautical miles, or whatever you're going to be doing your measurements in. You just want to make sure that you keep the math consistent. So don't start measuring in nautical miles and then halfway in between use a mile scale, or if you're flying by miles, don't accidentally make the mistake of flying by nautical miles. So you just kind of want to use common sense, and over experience you're gonna realize well, what to expect a distance of 25 nautical miles to be, or what to expect over a distance of 50 nautical miles. But just make sure you get the scales correct. So in this case I like to do everything by 25 nautical miles. So here you go. And all maps, and even if, let's say, you just didn't have a plotter, you didn't have an E6B, most of your maps are going to have some type of scale at the bottom. Even this Google Maps right here has a scale right there. Your sectional is going to have a scale, so at the very least you can take a straight edge and mark it and find out what your distance is by that. But that's just it. And all you want to do is you want to use your distances that your predetermined point. So you're going to have your point of origin, and then you're going to have your destination, and then you're going to have checkpoints in between. Those checkpoints being whatever that whatever you use as like orientation points or anything else. So okay, so now that we got that out of the way, that's how you figure out your distance. Next thing you're going to need to figure out is how to get your ground speed, because your ground speed is what you're going to base your fuel consumption off of. So for example, your ground speed is, well, you get to your ground speed through a series of modifying the numbers like you would with your initial true course. So this is very important right here. What you're going to do is you're going to go from your indicated airspeed to your calibrated airspeed, then from calibrated to true, and then from true airspeed to ground speed. Okay, so again, I'll say that you're going to go from indicated to calibrated, calibrated to true, true to ground. Okay, that's a series on how you will basically get to what your ground speed is. Now there's definitions of each one we'll talk about, but initially your indicated airspeed is what you're going to read off of your instrumentation, if you will, being your airspeed indicator. And initially, like, what do you put down for your indicated ground speed for your purpose of cross-country flight planning? Well, a lot of times it's a predetermined value, but what you will use is you'll just use whatever you expect your cruising speed to be indicated on your airspeed indicator during your flight. For a lot of training flights, people use about 110, 115 knots depending on what aircraft you're using. I like to keep it at nice whole numbers. So I'll use 120, or I'll use 110, I'll use 90 for example, but whatever you expect your indicated airspeed to be as you travel through the air is where you're going to base your math off of. Okay, so let's just say our beginning airspeed is going to be 110, for example. And on your little flight planning form, you'll just write down 110. knots. That's what you expect your speed to be. Well, from your indicated, you have to go to your calibrated airspeed. And your calibrated airspeed is basically your airspeed corrected for installation error. Now, the way you figure out what your calibrated airspeed is from your indicated airspeed is you will go by your pilot's operating handbook. There will be manufacturer data in there to tell you what your calibrated airspeed will be based off of your indicated airspeed. And they'll usually do two configurations, like flaps up and flaps down, for example, what your calibrated airspeed will be. So you just want to make sure that you get your you just want to make sure everything's correct as far as figuring out what your calibrated airspeed is. So in a typical, and I've tried to look on the internet to find a calibrated airspeed chart, but haven't really been able to find it. So you just want to look in your POH. Now from your calibrated airspeed, you're going to look for your true airspeed. Now this is what gets a lot of people confused, going from calibrated to true. To figure this out, you're going to need to know what you're going to have to use your E6B. So again, you can use your manual E6B or you can use electronic E6B. But I think in this case, I'll go ahead and show you how to use a manual E6B to figure out what your calibrated airspeed is. So here's an electronic E6B right here, and there we go. And I actually got this off of pilotInside.com, so they were really good enough to have a real manual E6B to use. So when I make this video, I can kind of show y'all. Even though it is a little bit hard to use, I really kind of wish they had brushed this up a little bit, but beggars can't be choosers. Okay, so let's say, for example, how are you going to figure out your calibrated airspeed? Well, first thing you're going to do is find out what your temperature is going to be. Okay, so what you'll do is you'll go to aviation weather. There you go. Then you'll look at your weather, and then what you'll do is you'll look up your winds and temperatures a lot for whatever area you're going to be in. So if we're in Houston, I'll look up winds and temps for Houston. There we go. I'll find Houston. And where is it? Houston. And then we'll see that our temperature isn't available at 3,000 feet. So what I will use is I'll go and use 6,000 feet just for purposes of showing y'all. And what we'll see is that the winds are 210 at 18 knots at freezing, basically 0 degrees Celsius. Okay, so what we'll do is we'll find out our E6B. It says right here, it says airspeed correction. It says set your pressure altitude opposite Celsius in window. Opposite calibrated airspeed on inner scale, read true airspeed on the outer scale. So we have our air temperature and we have our pressure altitude, thousands of feet. So all we do is we measure up our temperature winds aloft with whatever the pressure altitude is going to be. So we got 0 degrees over 6 right there. Well, man, I'm trying to... Okay, well, that's not quite it. Okay, okay, close enough. So then what we'll do then is once we have that, then we'll look at whatever our calibrated airspeed is on our inner scale, because our E6B has 3 scales. You have your outer, you have your inner. Well, you have really 2 inner scales, but when they say look at your inner scale, all they're really telling you to do is look at your inner wheel right here. So let's say our calibrated airspeed was 115. So this is 110, 120, 115, and then we got 125 right here. So our true airspeed would be 125. That is quite a difference, actually, right there. So what that means really is that even though your calibrated airspeed is 115, you're doing about 10 knots faster in the air, just because of the density, altitude, and the temperature and everything else associated with it. So the last thing you're finally going to do is you're going to figure out how to get your ground speed from your true airspeed, and I'll go ahead and do that in the next video.